everyone, welcome back. Today I'm going to teach you how to calculate the seismic loads by using equivalent static method, that is type 2 problems. So the problem is the plan and elevation of a three-story RCC school building is shown in the figure. The building is located in seismic zone 5. The type of soil encountered is medium stiff, and it is proposed to design the building with a special moment resisting frame. The intensity of dead load is 10 kilonewton per meter square, and the floor are to cater to an imposed load of 3 kilonewton per meter square. Determine the design seismic load on the structure by static analysis. What data they have given is, first of all, they have given plan and elevation. It is of 3-story and it is made up of RCC and it is a school building. It is located in zone 5. What type of a soil? It is a medium stiff soil, and it is a special moment resisting frame building. Okay, these are the basic information, and now we should focus on the dead load as well as a live load values. So dead load value is 10 kilonewton per meter square, and imposed load, or it is also called as live load, it is 3 kilonewton per meter square. Okay, the seismic loads has to be calculated by using a equivalent static method. So the elevation is, the height is 3.5 meter, 3.5 meter, 3.5 meter. Uh, the width between the two bay is 4 meter and 4 meter. Like that, they have given the plan. Again, it is 4 meter, 4 meter. This side it is 4 meter, 4 meter. Okay, now let's start with the calculation. Here they have not mentioned any condition, so I'm assuming it is a brick infill. Consider with a brick infill. This is a condition I'm assuming. So according to this assumption, a few values will change. So um, we should calculate VB, that is base shear. So base shear notation is VB and formula is AH into W, where AH formula is Z by 2 into I by R into rho A by G. This is the formula, and where W stands for seismic weight of the building. Seismic weight is total weight of the building, and we will calculate the W later. First we will focus on this AH. So in this AH, Z is a zone factor. Okay, zone factor value. How did I get this? 0.36 is, you should go back to the problem and check about the seismic zone. They have mentioned it as, building lies in zone 5. So according to that, I can decide this zone factor value Z. I will show you the code book. Here for this problem, I am considering IS 1893 part 1 2002 has, I'm referring this code book, and page 16. Go to page 16. There you can check table 2. You will come across zone factor table. So as you can see here, what are the different types of zone we have in India? It is zone 2, 3, 4 and 5. One is not there. So remember, one is not there. It starts from 2, ends at 5. So in the question they have given zone number has 5. So I should check this row. So it lies, zone 5 is this one. So zone 5 value is 0.36. So Z value is 0.36. So I have considered 0.36 in the calculation. Okay. Next, how did I take I has 1.5? For that, go to the problem and see here in the first line they have mentioned the building has a school building. This term is important. Here it can be a hospital building, school building, telephone exchange, anything. It can be anything. They would have mentioned anything in the question. So you should check for those terms. Okay. If school building was not mentioned, if they had mentioned only RCC building, they even that is fine. Okay. How these terms are related to this I term, I will show you in the code book. Here, go to page 18 and refer to this table 6. So you can, I guess you can clearly see here, table 6 is nothing but importance factor. In this we have first one and the second one. In first one we have a name of different buildings, that is you can see hospital, school, monumental structures, emergency buildings like telephone exchange. Many different names have been given here. Okay, so according to the problem they have given a school building, so it comes here. So the value of R is 1.5. So assume it, if they have not mentioned any type of a building, they have mentioned it is a RCC building. That's it. Then you should go for this line, that is all other building are equal to 1. Now don't get confused. Get back to here. Here it is a school building, so I should consider 1.5. So this is how I have taken 1.5. Next, the R value is 5 as they have given in the question. It is, you can read it, uh, building with a special moment resisting frame. That is, R is nothing but SMRF. I will show you in the code book. In code book, check page 23, table 7, that is response reduction factor. So here you can see, sorry, a building frame system. In the question it is a they have indirectly given it as SMRF, means it is a frame system. So SMRF stands for special RC moment resisting frame. So they have given SMRF, so take the value of R as 5. Okay. Next, Z is over, I is over, R is over. These terms are over, only rho A by G is remaining. I will show you that calculation at the end, or else let me show you now itself. Okay, rho A by G. How did I take these conditions? Means in question they have mentioned it is a medium soil site. So according to that, from the code book I have considered these three conditions. Okay, so refer page 16 in a code book, and uh, you can see here we have different conditions: rocky, medium, soil site condition. According to the question you should choose what conditions you should take up. Okay, our condition is a medium soil, so I have copied all these conditions there. So I have written that, and also these conditions depends on the value of t, that is fundamental natural period. So go to page 24. There you can see fundamental natural period. We have two different condition. For that, two different type of a formula is there. The first condition is without brick infill. If our condition is without brick infill, then in these two formulas we should consider one. But remember, our condition is with brick infills. So this is a condition there. So if it that is a condition, the formula will be Ta equals 0.09 into H. That H is missing in the code book. H divided by root D. Okay, where D stands for base dimension of the building. Now in my problem, I have considered this formula, that is Ta equal to 0.09 into h by root d. Okay, h is total height of the building. You should add each story height 3.5 plus 3.5, or you can multiply into 3 because all the three story height is same, so I'm just multiplying with 3, so I will get 10.5. And d equals 8 means we should refer the elevation. Here in elevation they have given the base width as 4 meter plus 4 meter, so like that d equals 8 meter. H is known, D is known. Calculate T. T is 0.334 seconds. So go back to these three conditions. Check that this 0.334 lies in the second condition. That is, it lies between zero point 0.1 to 0.55. So the rho A by G value is point not point 2.5. Okay, next substitute all these rho A by G, Z, I, R in AH. We will get 0.135. This AH value is ready. Now the most important calculation is the W value, that is seismic weight calculation in this problem. As I told, this is a type 2 problem. This seismic weight calculation is a tricky part in this type. Next, uh, the dead load calculation. As you can see a diagram here, it is a three-story building. One, two, three have mentioned, and the most important thing is what type of a load coming on each story. So I will start with the base. At the base, we will get dead load plus live load. Then at the second story, it is dead load plus live load. But when you move to the topmost story or at the terrace, only dead load is present, live load is absent. Please remember this condition, that is live load is absent on the terrace floor. So I have mentioned only dead load here. According to this I have done the calculation. So get back here, dead load on each floor, that is first and second floor. We have a first and second floor dead load, so I have calculated separately. So according to the question, it is 10 kilonewton per meter square into 64 means 8 into 8, that is area value. 8 into 8 you will get 64 meter square, then meter square will get cancelled. Answer is 640 kilonewton. Okay. Next, a live load. So live load is 3 kilonewton per meter square into 64 is a area, that is 8 into 8 meter square. Meter square will get cancels. Then what is this 0.25 is? That is a imposed load which is taken from the code book. Okay. See, refer page 24 and table 8. Here we have a two condition. Okay, live load is, according to our problem, the live load value is 3. Okay, so they have clearly given up to and including 3. We can take the imposed load in percentage, that is 25%. I can multiply the value uh, into 25%. So 25% is nothing but 0.25. So I have considered this 25. How did I take live load? In the question they have given it as 3. So for 3 I should take it as 25%. 25% means 0.25. So multiply that. So only I have highlighted in red color. So multiplying we will get 48 kilo Newton. Live load is present both on the base as well as a next story. So 48 is the answer. Then live load on the terrace, simply have calculated as separately, don't get confused. So dead load, sorry, not live load, I'm talking about the dead load, sorry for that. Dead load on the terrace floor is 10 into 64, that is 10 into 8 into 8, we will get 640 kilo Newton. The live load on the terrace will be 0. There is no live load on the terrace. As I told, this point is important, this is 0. Okay, now What is the total weight? It is, see here, dead load is present in all the floors. So 640 into 3. But live load is present only on the 2 stories. So 48 into 2. So total weight is 2016 kilo Newton. So this is how the W should be calculated. Now go back here. So W I have taken here, multiply AH into W, you will get VB has 272.16 kilo Newton. Next is a design force. Okay, this Q1 formula you will get it in the code book, that is page 24. You can see here that is distribution of the design force. Okay, from there I have taken and I have calculated this table. So here, one second. So three stories are there. I have written from the bottom. I have taken it as 1, 2, 3, and the weight is important here. From the bottom, dead load plus live load is 688. Again, next story it is dead load plus live load 688, and at the terrace it is only dead load is present. So 640 I have written. So remember, this second column is important. Don't do any mistake there. Then when you come to third column, from the base you should add the height. Base is 3.5. Again, next story is 3.5 plus 3.5, it is 7. 7 plus 3.5, it is 10.5. Next is multiply second column and the third column. We will get the numerator value of Qi, and the denominator is summation of all these values, that is 1,12,700. Next, numerator by denominator is a value what we required. So 70,560 divided by summation, we will get 0.62. Like that, do it for other values. Next is the lateral force, means Q1. Last column is Q1. We have numerator, denominator. Multiply that with a VB value. So VB value is 272.16. So this is a values we are getting: 168.73, 78.92, 20.14, and the last value is, like, if we do the summation we will get 272. That means our VB should match with this summation. VB is 272, and in this table the last value summation is 272. That means whatever we have solved, it is correct, and whatever last column I have got, I have just represented it in a diagram. Okay, hope you have understood this. Thank you.